All right, well, thanks for coming here. We're going to talk about Kotlin. Kotlin is a language that is a statically typed language. It is a language that compiles into several different platforms. It's one of those few languages that is truly a multi-platform language. You can compile Kotlin to the JVM, you can compile down to JavaScript, you can compile it to native, you can compile it to WebAssembly, you can run it on Android, you can do several things, native, iOS, Windows, what have you. So it's something that you can do in quite a number of different ways. But what are some of the special things about Android? I want to talk about some really cool things we can do with Kotlin, and then we'll talk about how to build some applications with it as well. Best time to ask questions is when you have it. I never take questions in the end. So if you have a question, speak up. I'll be more than happy to listen to you, and then we will just talk about stuff you want to talk about, and we'll keep moving. So if you have a question, just draw my attention. I'll be more than happy to listen to you. Please.
Does it compile to PHP?
Raise your hand if you want to throw him out of the room. We will talk about you in a few minutes. So let's talk about Kotlin itself. So Kotlin is a language with low ceremony. Well, you don't use semicolons. So in Java, of course, we are used to using semicolons. Dart uses semicolons. You said, well, Kotlin, you don't have to put semicolons. Your little pinky actually is very happy when you start programming in Kotlin because you're not abusing it with all that stupid semicolons we usually use. Kotlin gives you really nice, sensible warnings. This is one of the things you would appreciate when it comes to Kotlin. Yes, please.
Sound is good? Higher, lower? Good.
All right, awesome. So Kotlin gives you sensible warnings. So if you're making mistakes in code, you'll get these warnings so you can handle them pretty nicely. Kotlin has nice type inference. So you don't have to say what the type of variables are, at least local variables, and of course, it becomes a lot easier to infer some of these things. So how do we really write code in Kotlin? Well, you can say, for example, a val, and I can say greet, and I can say what the type is string, equal to hello, and I can write the code like that. And of course, I want to go ahead and print it out, so I can say greet right here, and we can run the code, and we can see that it prints the value of hello. And on the other hand, though, if you really don't want to, you don't have to specify what the type is. And the code will still work, and the reason is, of course, it figures out what the type is based on the context. So it knows that the variable greet is a type string based on what you assign to it. And as a result, you don't have to really give the type when you don't care about it. Of course, if you do want to specify the type, you can specify the type. Similarly, for functions, return types, you don't have to say the type. If it's a really small function, a single-bodied function, an expression. There are two different ways to define variables in Kotlin. One of them is to use this beautiful val. And val stands for immutable variables. You cannot modify a variable once you define it using a val. So if you try to go ahead and say, in this case, greet is equal to hello, you get a compilation error because val is immutable. You cannot modify it. Well, in Kotlin, you prefer val as much as you can. But of course, Kotlin also has one more thing called var. And if you want to know what var is considered to be keyword of shame. So if you use var, you don't make eye contact with your colleagues the rest of the day. You look at the floor when you walk, and they'll look at you and say, use var, didn't you? And then they'll come with you and refactor your code. So var is a mutable variable. As much as possible, don't use vars, prefer val. Of course, just to kind of illustrate this point right here, if I say greet is equal to hell rather than hello, I'm going to print the value of greet, and you can see that we are able to mutate that variable, and you don't want to really do this as much as you can, so avoid it. So there are two different ways to do this. Kotlin also has beautiful string templates. So as a result, it becomes a lot easier to write the code with it. For example, if I say name is equal to, let's say, Ted over here, I want to go ahead and print out and say hello, and then I can just put $1 and the name, and you can see that I'm able to print the value right there. So it becomes a lot easier to write string templates as well. You don't have much ceremony. Of course, if you want to get the length, you can put a little curly at that point, and then you can call the length on this to find out what the length of that particular variable is, or the value is. You can find out very easily, as you can see. So that becomes a lot easier to work with. let's talk about writing functions. Well, how do you really define a function? I want to define a function called greet, which is going to take a name as a string. And I want this to return, let's say, just the value hello, and then the $name like we just did. But Kotlin wants you to remember to have fun every time you sit down to code, so you define functions using this beautiful keyword called fun. So every time you write code in Kotlin, you can have fun and smile about it. So right there is the greet, which is a function. And then of course I want to call this function, I'm going to call greet, and I'm going to say over here Joe, and you can see that in this case it's going to return the value hello Joe. What about the return type of this function? The return type is inferred because it's a single expression function. Now just to illustrate the point, if I say val over here, let's say message is equal to greet, and I'm going to pass to this, of course, let's say Sarah right there, and I want to then print out the value of message, and you can see that in this particular case it prints out hello Sarah. What in the world is the type of message? Make no mistake, it knows the type of message is a string based on type inference. So of course, in this case, if I were to call, a function foo on this, that's going to be a foo, but it's going to be a string. And of course, you cannot really call foo on that. It doesn't really make it available. But just to illustrate the point, if I say message is equal to 1, for example, we know that message is a string type, and it tells you that you cannot reassign values of type integer. You cannot assign it to a string, so it kind of knows that it's a string, and that's based on the context. But of course, if you really wanted to, you could specify the type right in here, like string, and as a result now, you're assigning it to a variable of type string, and clearly, of course, that would work. On the other hand, of course, if you were to say integer over here, that wouldn't work because message is of type integer, the function is of course a greet, which is a string function, you cannot assign that, so the type verification works pretty nicely. So return type is inferred for functions. If it's a very small function, you can specify the return type. How do you do that? You simply go back over here and you specify the return type of the function right in there. And of course, in this case, I'll remove this part and you can run the code at the point and you can see how that's going to actually work. So given this, of course, if you notice how you define this, in Kotlin you put the name of a variable first, and then you put the type after that. Just to emphasize that names of variables are extremely important, because how many times have you seen developers give absolutely ridiculous names like P and Z and K and W? They want you to think about giving good names or respectable names and then the type after that. So that's basically what you're trying to do here. You can also have functions which are void. These are called units, and the reason is they want to treat everything as expression. So unit is a representation of void, so you're able to really use it as an expression as well. But one of the really cool things about this is you can use default arguments to functions also. So this becomes a really nice way to represent functions. So to understand this, let's go back to this code right now and call greet and pass, let's say, Scott over here. So when I run this code, it says, hello Scott, as you can see right there. But what if you tomorrow decide to change the message that you pass to this particular function? So what you can do then is you can come in here and say message colon string, but then you can specify equal to, and you can specify hi over there if you really want to. And then of course, as a result, you can specify this is going to be $message, and you can just evolve it like that. So when I go ahead and run this code this time around, notice it says hi Scott right there. And of course, if you really wanted to, you can call the greet function this time, pass Jane over here, but say howdy. And in this case, it says hi Scott, but also says howdy Jane. But one of the really cool things about Kotlin is, not only can you give default parameters, but the default parameters can also access variables to its left. So this is a very geeky way of me saying hi fi to my friend Scott. So I can simply put a $name.length over here. And as a result, as you can see in this case, when I run the code, it actually says hi fi Scott. So you can actually do that as well. So you can pass the default parameters, but you can also use variables to its left in the arguments, and you can make use of those values where it makes sense. Well, you can also use named arguments, and named arguments are pretty awesome because named arguments make it easier to understand the code by making it more expressive, and that becomes a lot easier to work with. And of course, you can also mix it with the positional arguments also, and like a lot of other languages like JavaScript, you can use var, args, and spread as well, so that gives you a lot of flexibility in how you can pass data to functions. Well, let's talk about some looping concepts, but one of the things I want to emphasize here is the language is very fluent, but it's something that you can use for your own code as well. So for example, let's say how we can use a for loop. So I'm going to say over here for example, and I'm going to say that in this case I want to say x, and I want to say x is a variable, a looping variable I want to use. And then I'm going to say that comes from in, and in this case I'm going to say let's say 5 for a minute. And then I can, of course, print out the value of x over here, and we can see what the value is going to be, and you can see its values 1 through 5, and that is included. But what if I don't want to include the value 5? What I can do is I can say, in this case, until, and I can write the code like this. So this particular code is using a function called until, and one is an object of type integer, and I use an until function on it. While this code actually works, we can agree that this code is a little bit noisy. But here's the beauty, the language actually makes things easier for us to what we want to do. So if I were to take this function, I can drop the dot from here, I can drop the parenthesis from here as well, and when I run the code you can see it simply works. And the reason for that is that the until function is defined as an infix function. So you can take your own functions and you can get the same benefit as well. So you don't have the noise of putting dots and parentheses around your code. So the code becomes very fluent, as you can see. So you can write things like x in 1 until 5 and so on. Similarly, you can do a step or a down to and step, so you can write this very fluently, if you will, as you proceed to write the code. One of the other things you can also do is to use beautiful list objects as well. And a list gives you ability to create a list of objects very conveniently. So for example, I can say fruits is equal to a list of, and I can then say over here, for example, apple, and I can say orange. And so this gives me an ability to create a list of fruit objects, and this becomes a very easy way to create a list. Now, one of the things I like about the way they have done this is that Kotlin does not use a different collection, especially when you're on the JVM, that is. So this literally is the java.util.array list under the hood. However, they did something brilliant. So if I were to go to this code, and if I say fruits.add, and I want to add a banana to this, I will get a compilation error. Why? Because I cannot do add on fruits, because fruits is immutable. Now what they did is something brilliant in my opinion. They took the same exact underlying collection, but on the top of it, they gave two interfaces. One is the list interface, and the other is the mutable list interface. Both these things point to exactly the same object, but think of this as two different doors or gateways. Through one you can do mutability, through the other you cannot. So as you can see in this case, it does not allow you to modify the fruits. As you can see in this example, the code did not even compile. On the other hand, I'm going to go back and say mutable list of, and in this case, we created a list which is mutable. It's exactly the same array list under the hood. However, you get a mutable reference on it versus an immutable reference on it. So what you could do is you could create a mutable object, but then you can pass around an immutable reference and be happy that nobody is going to modify that through that reference. So that can be really nice to have that kind of comfort that you're not going to be mutating this object. One of the things I love about Kotlin is its expressive nature, and that shines really well when it comes to using pattern matching. Well, when is actually an expression and also a statement. You can use them as interchangeably as either one. Let's look at a couple of different examples of using a pattern matching in this case. So I'm going to define a function called process, and this takes an input which is of type, let's say, string. And in this case, of course, I'm going to simply go ahead and print out when input, and all I'm going to do is simply say else. And what do I want to do when it is something else? I'm going to simply say whatever. So if I were to call process in this case with a value 1, call process with 15, let's call process here with hello. So when I run this code, what does it tell us? It gives us a warning. Well, those are the sensible warnings we talked about earlier. So in this case, integer does not conform to, of course, this is going to be any, so we'll change that to any. So when I run this code, you can see it is giving us a warning, but then it says whatever for all the 3 values. But what if I go back to this code and say 1, and then I'm going to simply print out, let's simply say got 1. So when I run this code, you can see it says got 1 for 1 and whatever for the other 2 things. But what about 15? I can say this is a value in, and I can say 13 to 19, and then I can simply print out got a teen. So you can even check if the value is in a range, if you will, and that becomes a lot easier to look for got a teen. And similarly, you can also say isString, and you can simply print out, for example, got a string. So you can see how easy it is to write this code using a very elegant pattern matching syntax, and that worked really nicely. Now, not only can you do all of these beautiful things, but the language actually goes really good in terms of making things extremely easy for us to work with. Now let's think about this for a minute. So I'll come back to this code in just a second, but imagine this is Java just for a few minutes. So if you're writing Java code, suppose you have a class and you say public static process, and this is an object input, let's say. And then within this you output the value for input. And then you are going to call this function process with the value 1. And you're going to call process with, let's say, hello. Now I want to know what to do if it's a string. So what do I normally do? I say if, I say input instance of string. Well, Java will tell you whether this is a string or not. Clearly on line number 10 it is not a string. Line number 11 it is a string. But then I want to simply say over here, output, and I want to say got a string of length, and what do I want to do? I want to say plus input right here, dot length. Will this work? No. What do I have to do? I have to write some beautiful code here, isn't it? That's just absolutely beautiful, and you have to say string right here. And then you have to cast that string into a input to a string, and then once you cast it, you can call the length, isn't it? Now, does anyone remember what this feature is called? Casting. Yeah, casting. That's what they call it. I call it punishment. Because that's what you do here, isn't it? You already asked, is it a string? And the language said yes. And you come over here, and it says, do it again. Right? And this is like, what's happening here? You have to work extra hard. And the compiler is sitting there and watching you. It's to keep going, and you're like, can I have lunch please? No lunch for you. Go ahead and do some more casting, right? And so you have to do all this work, but why? For no good reason. Let's think about this one more time. I'm going to go back over here. This is Kotlin code one more time. And what am I going to do at this point? I'm going to say got a string, and I'm going to say of length, and simply put a dollar input.length and run the code, and notice the output says that got a string of length 5. Make no mistake, you cannot do this up here. Suppose you were to say input.length up here, you'll get a compilation error because it is not a string at that point, it's only a string after it's confirmed. So that is called a smart casting, and the language is pretty sensible in terms of casting automatically for you, so you don't have to waste your time and effort to cast it. So we saw some of the nice things about how you can use this. Let's talk about null. Who likes null over here? Oh, come on, be honest about it. Yeah, I know he does, because I found it. And so absolutely, that's him, by the way. And there's no wonder he wanted to know if you can compile it to PHP. I'm watching you. Okay. So null is a smell, isn't it? And there's a reason why nobody's sitting behind you, if you noticed, right? so null is a good sport. Thank you. So null is a smell, of course, and it really becomes a problem when you write code with null pointers. Because what happens, you get an accidental null pointer exception in the code. Now, accidental null pointer exception is annoying because you didn't expect somebody to return a null, and somebody like him just return a null on you, and you're not able to handle it properly, and you really suffer with it. So what did Java do to prevent null pointer exceptions, or at least address that? So here's what Java did, right? So Java said, we got an idea, if you write public, get something, and of course, in this case, if you don't have something to return, you could say optional of string. And what was the intention of this in Java? They did this in good faith. And they said, if you don't have something to return, then return optional of what? Empty, right? That's what they are supposed to do. But you know how some programmers are? They are so adamant. And they come here and return a null to this. There's no way to win this battle, right? Because what happens now? Now you get a null pointer exception one more time. There's no way to win this. So Kotlin says, let's get to the root of this. So in Kotlin, you cannot just return null arbitrarily. There are two categories of type in Kotlin. Let's take a look at an example here. I'm going to create a function called, let's call it as nickname. And I'm going to take a string, and take a string which is going to be a name of type string. And then from within this function, I want to return a string. But what do I want to do here? I'm going to say if the name is equal to Robert, I want to say return, let's say Bob. Otherwise, I'm going to simply return, let's say just a few dashes right now. So then I can call this function, for example, I can say println, and what do I want to do? I want to say nickname for Robert. Now, nickname for Robert is, of course, Bob, and it goes and prints the word Bob for me when it becomes that particular type, and that's what we should be able to see as an output. But what if we want to say that if we don't know what a nickname is, we want to return a null? So in this case, I'm going to say null right here. And then, of course, if I were to call this one and say nickname for, let's say, in this case, Venkat, and what does that do? I want it to print a null if the name is Venkat. But the code will not compile at this point. Why not? Because you cannot really pass to this particular function or return from this function a value of null because a string is not nullable. If you really want to return a null, you have to provide a nullable type, which is a question mark at the very end of the type. So null, string cannot be null, but a string question could be a null in addition to these references. So you're giving a very clear directive saying that do expect null, I might be returning a null. So when you run this code, you can see it said Bob for Robert, but said null for Venkat. Just for the sake of record, null is not the nickname for Venkat. But in this case, of course, I'm returning a null. But how do I get the value out of the null? Well, if I want to know how many characters exist, I'm going to call length on it. But you know that's a disaster. Because if you call a length on a nullable object, it'll blow up with a null pointer exception. So the compiler should not permit this, and as you can see, the compiler does not permit this. And the compiler says, sorry, you cannot do it. You got to first check if it is null. If it is not null, then you can call it, otherwise you can call it. Well, this brings us to what is called a safe navigation. And the safe navigation says, if the value exists, call that function. If the value doesn't exist, skip it. So what's going to happen now? If I go here and put a dot over here, and then of course I call length, well, Venkat, the value is null, and of course as a result, when you look at the output, it gives you a null. But what if I don't want the null? Maybe I want to replace it with a value if it were a null. Well, you can again write a very concise code by using a special operator, and I'm going to return a 0 if it doesn't exist. Now, what is this called? This is called the Elvis Operator. Somebody had a lot of free time and imagination. They called it Elvis because if you put your head like this and see, this is beautiful Elvis's hairstyle, right? And that's why they called it Elvis Operator. Yeah, somebody had a very good imagination. So the Elvis Operator, of course, is really cool, like Elvis. And as a result, of course, this gives you ability to substitute a value if the value is null, otherwise use the value if it were to exist. So that becomes a really nice way, a very type-safe way to deal with nulls, as you can see. And of course, I talked about auto-casting already, the smart casting we can use. Well, here's something really beautiful about Kotlin. Kotlin is a multi-paradigm language. As a result, in Kotlin, you can write code in Kotlin to write imperative style code, to write object-oriented code, and you can also write code in Kotlin in the functional style as well. So you can pick and choose whatever that may make sense for you based on what you're trying to do. So for example, if I were to create the fruits as we did right earlier, and I'm going to say list of, and I'm going to say apple, and let's say orange. So now I can simply use a for loop. I can simply say in this case, fruit, and I can say in fruits, for example, and I'm going to simply print out the fruit given to us. So this gives us a way to do an imperative style of coding to start iterating over. Now Kotlin is a very sensible language. Now what if somebody writes code like this, and they take this fruit, and they try to mutate this fruit, and they put a banana right there. This is a really bad programming, isn't it? Why would anybody take that variable and mutate it? That's terrible. So Kotlin will not permit you to do that. So when you try to run this code, it says, what are you trying to do? Val cannot be reassigned. I know some programmers are really desperate. They will say, really? And they'll put a var over here. And Kotlin will be really unhappy and kick them out. So you cannot, because it doesn't make any sense at all to make it mutable, so the language does the right things. So that object, that reference is immutable, which is the right thing to do. That, of course, is imperative style. Even that is much better. But you can write the code in the functional style as well. So you can say fruits over here, a dot, and you can say for each. And for every single value, you can say, given a fruit, what do you want to do with the fruit? I want to print the fruit right in there. So this gives you an opportunity for you to navigate and print the objects. Now when you look at this code though, the real syntax of this is a parenthesis, and then you put the parenthesis around this, and then you pass a lambda expression through it. Now, while you can write code like this, if you have a function that takes multiple lambdas or multiple parameters, then if the last parameter is a lambda, then you can leave out that parenthesis, and you can hang the curly right outside to make it a lot more concise and expressive and less cluttered, less noisy. So this is only afforded for the last argument that you pass to a function if it were a lambda expression. So in other words, the last argument to a function is very special. It's kind of like the last children at home. The parents always treat them very differently, isn't it? I know it because I was not one of them. And that's how it is, treating them very differently, as you can see. But you can also go a little further and say, instead of passing this parameter, you can simply say it, just like in Groovy. And this, of course, becomes a very easy way to refer to it. So if you don't care to give a name for it, you can just call it, and you can just use it. And so that becomes a very nice way, elegant way to pass this. Well, you can now start writing some very elegant code with this. For example, you can say a fruit dot, and you can do a filter in this case. And then once you use a filter, you can say, given a fruit, you can do something with the fruit. Like, for example, fruit dot starts with. And then you can ask if it starts with the A, for example. And you can get only fruits that were to start with an A, for example. And then you can disregard every other fruit if it doesn't start with an A. And then you can do a for each again, and you can then navigate through it, and then you can get all the fruits. In this case, we only got an apple. Or you can simply take this and say a dot map, and then you can say, given a fruit, of course, I want to say fruit dot to uppercase, and then you can convert it to an uppercase, and then you can print the value, in this case, of course, apple, all in uppercase. So you can write a beautiful functional style code as well, and that looks really elegant and easy to express. So you can use that code in the functional style, and you can definitely work through that. So you can do things like filter and map and reduce. All the functional style facilities are available. Having said that, extension functions are all over Kotlin. You're going to see this almost every corner you turn. Sometimes it's really like, wow, is that extension function? And it turns out it's an extension function. There's so many of these. So what's an extension function? This is a lot like what's available in C#. Well, classes really are open. Okay, that's not entirely true because people who know Kotlin will disagree with me. But what I mean by that is classes are final, which means you cannot extend from a class. But classes are open in the concept of meta programming. You can add methods to classes. Let's think about this for a minute. Suppose you have a greet over here is equal to hello. Now what in the world is this greet? It's a string, Java lang string. Now, I want to say greet and print greet, and of course the value is greet. But imagine you see a long-time friend after a very long time. Would you just walk up to them and whisper hello? No. If you're like me, you'll scream hello because you saw them after so long and I know everybody around you isn't it. So I'm going to just simply call a shout method on the string to convey my excitement seeing a friend after a very long time. But when I run the code, how sad the JDK does not have a shout method. Does anyone agree that JDK should have a shout method? Absolutely, isn't it? But it doesn't. But we don't have to take no for an answer. We can provide a shout method if we want to. So notice what I'm going to do. Trust me, it's a lot of fun. And then you say string.shout. And you simply provide the implementation to uppercase to express your feelings about seeing the friend after a long time. And when you run the code, you can see it says hello all in uppercase. Now this is called an extension function. You are able to take existing classes. I know what you're thinking. You're thinking, wait a minute. Did you take the sacred java.lang.string and add a method to it? Exactly. How come? Well, the last time I checked, we live in a free country, isn't it? We can do anything we want to do the code we are writing. So we can just take this code and add functions to this. But the beauty in Kotlin is, this is not modifying the bytecode. It is not touching your class in any way. What they actually did is they wrote a static method called shout. That static method takes one argument in this case, or one more argument if it already took parameters. And that is of type string. And so internally, what the compiler does is if that static method is imported, if it's in scope, it'll immediately turn around and call the static method, so it's purely a syntax sugar. Now, not only can you do this is pretty awesome, but then I came across something that really bothered me. I was giving this talk in a conference, and a gentleman was sitting kind of like where you are sitting, and his excitement was amazing at this point. He was like, oh, excuse me. I'm like, yeah, what is it? He said, can you do the following, he said. And he wanted me to call to lowercase right here. And then he wanted me to take this to lowercase and change it to uppercase. And then he said, can you do this? And when I ran the code, what it did was it printed the to lowercase in uppercase. What bothered me was not the fact that Kotlin lets you do it. What bothered me was how satisfying he felt when he could do this. We had to take him out of the room, like you, in this case, because that's kind of dangerous. So just because you can doesn't mean you should. So don't do these kinds of things. That's really bad. But this becomes really easy way to extend your class with methods, if you will. And so this is really not part of the class like I mentioned, but you have to be a bit careful. But extension functions are everywhere. So that becomes a lot easier to take functions, classes, and extend them with new functions. What about object-oriented programming? Well, Kotlin provides really good support for object-oriented programming, a lot more than Java does actually. But let's think about this for a minute. How do we write code in Java to write a class? Well, you know what? Java came with a historic background and baggage, isn't it? Java had other visions and other desires. But when everything was said and done, what do we typically do? Here's how you write a class in Java, isn't it? You say public class car. And then what do? You say private int year. Are you done? Oh no. Public int year, get year. Isn't that beautiful? And then what do? Return year. Are you done? No. Public void set year. And then what do? Int value. Then you say year equal to value. And you would be spending your time writing all these getters and setters. I know what you're thinking. No, I don't. All I do is, I write the field, and then I gently right-click on it. And before I can blink my eyes, Java, the IDE, will vomit the rest of the code. And then what happens? You got to live with the vomit for every day after that. You open the code, and in front of you, it's like, my dear God, I don't want to see this again, right? Now, why do we have to write all of these things? Why can't the language be intelligent to write these for us, so we don't have to? Well, good news, in Kotlin, you don't define fields, period. You don't define fields at all, because fields have no purpose. And so you don't define fields. So I'm going to say over here, class car. And I'm going to then go ahead and print out car, a new object of car. I'm creating that object and I'm printing that object. That's the minimalistic class. You did not even put a curly braces because there's no reason for ceremony, right? Why? There's no reason to do it. But then what you can do is you can say val and you can say year, which is an integer. Then you can come in and say 2019, and now you defined a year property. So you can simply say dot year over here, and as a result, you are able to get the value of the year, which is a property in this particular class. But of course, it's immutable. Why? Because you defined it as a val instead of a var. But had you defined it as a var, then you can mutate it as well. So what you can do then is you can say car dot, well, you got to have a car object, of course. So val car over here. So car is equal to car. Did you know? Remember, notice you did not use the word new. I know this is a really sad way to put it. There is nothing new in Kotlin, right? So you don't use the new keyword. It's a Python syntax to create objects. So in this case, I'm going to say 2019. And then, of course, I'm going to print car.year, which is 2019. But then what do I want to do? I want to modify it. I can say car.year equal to 2020, for example, and print car.year. And when I do this, it is going to change the value of the year. And of course, we're able to print it. Let's see what happened over here. On line number 8, it was not too happy. Oh, it's a lowercase. Thank you. Yes. So let's go ahead and run this code. And you can see the year value is 2020. But of course, I know what you're thinking. You're thinking, I got an idea now. Why not simply say over here, change it to a different value? What if the value were, 2019 to begin with? And you can try to change it. Or what if this was a value for miles? So miles is going to be, okay, so kilometers, sorry. So if it's kilometers, what do you do in this case? Maybe you want to change the value of kilometers to something else. So I could say, for example, it is, it comes with 1,000 kilometers when you buy the car. Now what do I want to do? I want to print the kilometers to know how many kilometers I have on the car. And then of course, when I go back and run this code, I can see that the value of kilometers is going to be 1,000 because that's a variable again. And of course, in this case, you can make that immutable. So, but what if you try to come up with a malicious plan? You say car.kilometers is equal to, let's say, 10. That's the best way to keep the car new all the time, isn't it? And then of course you're going to print the car.kilometers, and of course we shouldn't be doing this, we should disallow it. How do we do that? Well, the beauty is, even though these are properties, you can write getters and setters for the properties if you will. So what I'm going to do here is I'm going to take this property, let's go ahead and say in this case, we have this property which is the kilometers. Let's say that I'm going to define a var, kilometers as an integer, and let's give it a value, let's say some value of 0 to begin with. And I'm going to assign a value later on, so I can come in here and say car.kilometers is equal to 1,000, let's say. And I want to print the value of the kilometers once I assign to it. So it went from a 0 to 1,000. But then I say car.kilometers is equal to, I want to set it to a 10. And I want to print car.kilometers. And of course, unfortunately, right now you can see it changed the value to 10. But I shouldn't allow that, isn't it? So what am I going to do? I can go here and I can write a setter. And I can write a setter and say give a value which is of type integer. And then what do I want to do? I can then say over here, field is equal to value. I know this is a little bit redundant at this point, but I just took that word field represents the field. You cannot say its name directly. So you can use the word field, and internally, whatever that field is, you're assigning a value to it. But what you can do here is, you can say if the value that you provide is less than the value of the field, what do you want to do then? I can say throw runtime exception, setting value which is less. How dare we will come burn your village. So you can put all these beautiful exception messages, right? And so if I were to run this code, it is going to then verify and say, how dare, setting the value which is less, how dare will come burn your village. So you can check for these and disallow, so that becomes a really nice way to implement it. So you're not drawn into ceremony. You can write minimalistic code, and then you can move into writing more code if and when you need it. And of course, it gives you fairly good amount of safety at this point, as you can see. Well, that gives us an idea about the properties in the backing field. You can also make the setters private as well. If you only want to set it within your object, you can do that by making it a private setter. Similarly, you can create static methods also, just like you would do in language like Java, except you don't define them as static methods. You define them using companion objects. That's a concept that is very similar to Scala, for example. And when you create companion objects, the companion objects contain the methods which eventually become static, conceptually at least, and that's how you're going to handle it. So by way of companion objects. But one of the other beautiful things is, you have what are called data classes. So what is the purpose of a data class? I say class person, and the class person has a first name which is a string, and it also has a last name which is a string also. So what am I going to do here? I create an object here, Alan is equal to person. I'm going to say Alan, comma, let's say Turing right here. But I want to print out Alan. How sad when all that it prints out is sample $person. That's no fun. So what am I going to do now? Well, you could go back over here to this code and you could write for yourself a toString method. Sure. And let's say you finish writing a toString method. And then you realize you want to compare two objects. And what do you normally do? You write an equals method. And the minute you write an equals method, what happens? You have a bug, isn't it? Because if you write equals, you got to write hash code. If you write hash code method, you got to write equals. And if you forget to write one, you don't get any errors. But why bother writing all of that? Why can't the compiler do that for you? Well, sure. All you do is simply say data class, that's all you do. By marking it as a data class, you've got several things for free. You got a constructor, which is already there in the top. You got a toString method, an equals method, a hash code method, and also a component end method, which is used for destructuring purposes. So this becomes really easy to write code with a data class, and so as a result, it's a lot less ceremonious. You can also, of course, use inheritance. How do you write inheritance? You have a class called person right here, but I can say class, and we could create a special person. And a special person could be inheriting from a person. So you use a colon to use the implementation. You don't use the word extends. So this is like what you do in C#, is the colon syntax to perform extending. And of course you can put all these parameters you want to pass. But by definition, this will not work because classes are final by default. Unless you mark them as open, then they are not final. Otherwise you'll get a compilation error. So you can use inheritance pretty nicely. But one of the really cool things about Kotlin is, not only can you use inheritance, but you also have a special syntax for delegation. So what is delegation? What is the purpose of delegation? Well, delegation is where you want to take the methods of one class and route them to another class. So we typically, how do you typically create delegation in the case of language like Java? You provide a field, and then you write all these methods, and you keep calling into the field over and over and over. That's a lot of typing to do, isn't it? And even if you were to type really fast, you still have to maintain that code. That's a lot of vomit again. That's a noisy code you have to maintain. And if the signature of the method in the original class changes, your code is broken. What if all this routing can happen directly for you? That is exactly where delegation comes in. So delegation is baked into the language as a feature. And the way you use delegation is by using a keyword called by, B-Y. And you're able to just delegate using that syntax. I'm going to show you one example of delegation. In this case, I'm going to show you the example of delegation for providing lazy evaluation. So what does that really mean, lazy evaluation? Let's take an example here. I have a compute function which takes an integer, and in this case I want to return an integer as a response to this function. But within here I'm going to say called, and then I will simply return n times 2. But imagine that this is a very expensive function, though it's not. I can say val x equal to 4. I can say if x is greater than 5 and the compute of temp of x is greater than, let's say, 7, I can print out here path 1 with the dollar compute of x. Else I can print out right here a path 2. When I run the code, we have a good news, isn't it? The good news when I run this code is it did not call the compute method. Why didn't it call compute? We know that feature is called short-circuiting. That's great. Unfortunately though, if x is 14, it is going to call compute, but it's going to call compute twice, isn't it? And that's pretty nasty. Why incur the price twice when you're calling compute? That doesn't make any sense, isn't it? Well, here's an idea. Why don't we take this one here and call this as temp, and then we call this one over here as temp, and then we can simply say temp is equal to that. Well, the beauty of this code now is that you're not going to compute it more than once. When you run the code this time, it unfortunately though calls compute, even though you don't need to call compute, isn't it? Why not? If the value is 14, hey, that's great. I need to call compute. That makes sense. But on the other hand, if the value is not 14, if it is 4, it shouldn't be calling compute, but yet it does. Why? Because we're assigning it to a temp. So what can we do? Well, we can go to this code and say val temp by, and we can say lazy, and we can just drop that into a delegation. So that basically says, if I don't have to call it, don't bother calling it. And as a result, it defers the evaluation by delegating. But of course, if you set 14 right in here, and if you fire this up, notice that in this case it calls it, but it only calls it once, because it caches it after it makes the call. So that becomes pretty efficient. Please.
So the logical operators like in Java, short and long circuit is not the same here as in the Kotlin.
Logical operator like which one?
Like short and long circuit, if you have one AND operator and two AND.
Oh, they are very similar. But even in Java, you will call it if you put it to a temp.
Yeah, but if the first condition of the boolean is false.
Yeah, it will call the second one.
Yes.
Yeah, and even in Kotlin it doesn't. That's what we saw a minute ago, right? So if I go back over here, and if I say compute over here of x, and of course this becomes a compute of x, because x is less than 5, it doesn't call compute. So it is short-circuited. But if you were to assign to a temp over here, and assign this to a temp right here, and of course if you say temp is equal to compute of x, that's a different story. In that case, of course, it is going to call it because you're assigning to a temporary variable. That's the same thing in Java also. In Java, it'll call the compute even here. The difference is in Java, you're stuck with it. Whereas here, you can mark it as lazy. And then you can say, defer the evaluation, I don't want to call it. And then you're able to gain on it. So this will not work in Java unless you use something like Project Lombok, for example. So that's about delegation. Of course, delegation is a lot more than lazy, but take a look at it if you're interested in looking at it further. But this leads us to a beautiful concept of using fluency in code. So this gives us an ability to write fluent code. So let's define a class called pizza. Within the class pizza, I define a spread function. It takes a topping, and that's a string. And all I'm going to do is print out, let's say, spreading, and then we'll put the topping right in there. So I want to create an object of pizza, and in this case, pizza is equal to pizza. Then I say pizza.spread, and let's spread some sauce on it. Not source, but sauce. So, so once we put a sauce, let's say pizza.spread, let's put some cheese on it. So when I run this code, it's going to say spreading sauce and spreading cheese. Well, that's great. Wouldn't it be nice if we can remove some of the noise in the code? We can remove the dot, we can remove the parenthesis, and we can remove the parenthesis from there. Well, that doesn't work, but it gives us a clue as to why it doesn't work by telling that we can use infix. So you can mark your methods as infix, and then when you run the code, you don't have to use a dot and a parenthesis. So this removes that noise in the code. Of course, this is only available if the function takes exactly one parameter. That's a limitation. But what you can do is you can start combining things quite a bit. So for example, if I were to change this to pizza, and then if I say return this right here, then I can simply go to this code and I can start putting multiple things like that to combine it. And we can start creating a very fluent syntax. And this leads us towards creating DSLs, or domain-specific languages. And that gives us a nice way to create fluent code as well. And this can become a very powerful way of creating a very fluent code. And so take a look at some of those features if that draws your interest. Kotlin has coroutines. So what are coroutines? Coroutines were introduced into Kotlin 1.3, and coroutines are a nice way to write both concurrent code and parallel code. So you can start writing code that is non-blocking, that is asynchronous, if you will. And this is a very powerful idea of how you can write code to run in multiple different threads. Let's take a look at one example of this just to get a feel for this. I say task 1, where task 1 simply prints out right here, entering, let's say entering task 1. Then I'm going to say over here, print line, and I'm going to say exiting task 1. So then I'm going to create a task 2 right here. And the task 2 says entering task 2 and exiting task 2. But just to add a little bit more interest in here, let's go ahead and print out right there a thread.current thread so we can see what thread is executing that code. And let's print that here, and print that here. But then I'm going to go ahead and call a function right here. And I'm going to say over here, task 1, call task 2, and once I call task 1 and task 2, I'm going to simply print out made the calls, and I'm going to simply print thread.current thread. So when I run this code, what does it tell me? This should be absolutely trivial to understand, isn't it? It's exactly doing what you expect the code to do. So it enters task 1, exits task 1, enters task 2, exits task 2. And it says, made the calls and prints all of them running in the main thread. Well, that's great. It's executing in the main thread. It's sequential code, nothing really exciting at this point. Let's go a little further. Let's do an import. And in this case, I'm going to say Kotlin x.coroutines, coroutines.star. So I brought in the coroutine at this point. Then I'm going to say over here, run blocking. So what does that really do? At this point, not a whole lot. If you look at the output of this code, the output is exactly what it was before. Nothing was really made different. Except this code right now is a coroutine. And that coroutine is executed, and your main is going to wait until you finish the coroutine before it continues after the run blocking. As the name suggests, it runs blocking. It calls a coroutine, waits for the coroutine to finish. So what is a coroutine? Well, subroutine is a function you call, and you enter and you exit. And when you call again, it's a new call every single time. Coroutines remember the state of a conversation based on a data structure called continuations. So how would this work? Here's how coroutines solve the problem. When you write subroutines, how does this behave? Imagine I saw you yesterday at 6 o'clock, you were heading out. And I look at you and say, hey, where are you going? And you say, I'm going to go to this movie. And maybe this morning I see you and say, hey, did you go to the movie? And you said, yes, I did. Here's how conversations shouldn't happen, isn't it? I ask you, did you go to the movie yesterday? I did. How was it? How was what? That's not the way you communicate with people, isn't it? That'll be a really boring person to talk to. Did you go to the movie? I did. How was it? How was what? We remember context, isn't it? If you don't remember context, how does it feel? It's like Dory in Finding Nemo. Hi, I'm Dory. Every few minutes you have to reintroduce yourself, isn't it? Because it forgets the context. So the point is, you want to be able to carry that conversational state forward. So what are we going to do here? Well, notice, I have this function, but I'm going to say over here, launch. So I say launch, and I launch task 1, and I launch task 2. Now, I make these two calls completely asynchronous. And as a result, when I run this code, notice the very first line of output is make the calls. It said make the calls first, because line 14 and line 15 have been dispatched. And you ran line 16. And then you came back and ran line 13, and then 14, and then you ran line 15 after that. That is asynchronous, isn't it? But you are still in the main thread all along. But then you say, wait a minute, what if I have some work to do in task 1 that is going to take some time? Think about this for a minute. If you have a work to do that's going to take some time, you don't want to block on it and wait. You want to be non-blocking. Imagine this for a minute. You come to work in the morning, and what's the very first order of business? Be honest about it. To fill your coffee mug with coffee, isn't it? Before you do any work. So you sit down at your desk, and you realize you've got to fill your coffee mug. So you take your coffee mug, you go to the coffee machine, and what do you realize? Damn it, the coffee machine doesn't have coffee in it. So what do? You turn on brewing. And then what happens? You don't move. Because you refuse to even breathe without getting the cup of coffee, right? No, you don't want to be blocking and waiting. So you turn on the coffee pot. While it's brewing coffee, you go do other things. And then, of course, you come back and get the coffee when it's done. So how do we do that? Well, I come into task 1. Before we do this, look at the output one more time. We said, make the call, we entered 1 and exited 1, entered 2 and exited 2. Now, I call yield over here. And I call yield on the second one also. So what does that mean? I'm saying, come into task 1, do that task, but don't block. Just go back and do what we want to do. When that finishes, you can come back and continue here. Well, before I make this code to run, we have to make one very sad change. This is one thing I don't like in Kotlin. I've made a formal complaint about it. Kotlin is a beautiful language, as you can see. It wants you to remember to have fun every time you write code. But if your code is non-blocking, you say suspend fun. How sad that is. Really terrible, isn't it? This is really, really sad. You have to mark it as suspend fun, and you got to suspend the fun. So in this case, you mark this method as a method that can be suspended. Now, when you run the code, notice what just happens. You make the call, you enter task 1, but then you enter task 2, all in the main thread. And then you exit task 1, and then you exit task 2. You are completely non-blocking. So right from the middle of task 1, you went off to do task 2. While the coffee pot is brewing coffee, you were sitting and replying to an email, right? Maybe a little grumpy because you don't have the coffee yet. But the point is, you can context switch between functions without being blocked on it. And that's an example of how you can move around. But of course, if you want them to be running in a completely different thread, you can do that as well. And the way you do that is by using a context. So you can say with the context, and you can do something along these lines. You can say with context, and this can be dispatchers.io. And that could be a IO thread pool you can create. And then once you do, you can do the launch within that particular context. And as a result, what does that really do for you? In this case, you are saying, I want to run it, but I want to run it in a completely different thread. Notice the threads that run right now. Entering task 1 on worker 3, exiting task 1 on worker 2. As you can see right there. It context switch between threads as well in that pool, as you can see, because it's non-blocking. And you can switch across threads very easily. Now that brings up a very concerning point. If you're going to be running across these multiple threads, this looks really awesome, but there's one time when you don't want to do this even by accident, which is in Android. In Android applications, your UI should not be modified from multiple threads, because UI is not thread safe. Yep?
I haven't quite understood why I can enter on one thread and access on the other.
It's not blocking. So the thread is not, just like you don't go wait on a coffee machine. You could go on the coffee pot and you could go check email, right? And as you're checking your email, maybe have a very wonderful colleague of yours who's a good friend, and your good friend says, I'm going to go get something, do you want something? You say, yes, get me a cup of coffee, please. You turn on the coffee pot, but your friend is going to get you the coffee. You don't have to go get the coffee. So you can switch between threads because it's non-blocking. The task is blocked, but not the thread. And another thread can go pick up that and finish it.
But what about thread local variable?
Yeah, that you have to manage. Yeah. But that's generally a bad idea anyways, right? Mutability leads us to more trouble. But if it's a transformational state, that's not a problem at all. So this gives you an ability to switch between them really nicely. So given this, of course, if you're doing Android, you don't want that to happen. Why? Because UI threads should not be accessed from multiple threads. That would be a disaster if it happens. That's one of the beautiful things about Android and Kotlin. You can use coroutines in Android. How do we do that? So here's an idea. This is a very small program here. Android's main activity. And what am I doing here in the main activity? This is an app compact activity, but I then also inherit from the coroutine scope. And once I inherit from coroutine scope, that requires that I implement a coroutine context. And in the coroutine context, you return dispatchers, excuse me, .main. This option is not available in the Kotlin library. This is available only when you use the Android SDK. So what does this do? This will automatically switch your queries to run in the main thread. So you'll never have a race condition. So you can launch your task to run on other threads. When your threads finish and come back to your code, they run in the main thread. So you can safely update your UI in the main thread, and you can run your task on a different thread. Like for example, let's look at this code right here. I am calling this function here, get airport status. And I want to go get status of airport for different airport codes. But what am I going to do here? I'm going to go get the airport code for it, call it get airport status. And when I get it, I can call this airport adapter, and then I can bring in this adapter, and then I can ask it to update all the airports from update airport status by passing the airports. But how does this really update the data for my airports? Well, the answer to that question sits in here, just as an example. I call a launch, and I say update airport status. So this is going to fire it off in another thread at this point for it to execute asynchronously, not blocking. And that's going to go off. My thread is not going to block over here. If I look at the adapter on the other hand, here is my update airport status. And what am I doing? I get the airports, and I go to the airports, and I clear all the airports in my view, and then I add the airports given to this, and then I say notify data change, and at this point it's ready to walk through and update the data for the airport. But this update of the UI will happen in the main thread. How so? Because my UI thread is running in the dispatcher's main. My task to go get the data from a server runs in a separate thread altogether. But I finish it, I fall back on the main thread automatically, so it's very thread safe for me to use it. So that's one of the biggest benefits you get out of doing this, is that you got that thread safety in running your code. So this can be a very powerful way to switch between your threads and the main thread without being stuck on things. And also one other thing. Here in this example, my view contains a number of these widgets. And when I want to use these widgets, I can simply use them without much ceremony. Because those properties from the XML document become available for me within my Android Kotlin code naturally because of preprocessing. So as a result, I can simply call isEnabled directly on that property. I'm not wasting a lot of boilerplated code. I just simply reach into it, and that comes to life, and that becomes a very natural way to write the code. And then that saves a lot of time and effort in writing the code. The code is pretty concise compared to what you would write in Java as well. So that is an example of how you can write these code to run in Android devices. So to summarize what we talked about, Kotlin is a language that is a lot less ceremonious. You can write code in Kotlin. So here, I wrote Kotlin code as a script so far. And as you write it as a script, you can run it as a script very naturally. For example, I can simply say hello, and I can run it as a script, as you can see, without much effort. But if you really wanted to, you can compile it down to a bytecode, if you will. So for example, I'm going to move sample.kts to sample.kt. Let's take the sample.kt file. And in the sample.kt, I want to write the main function. How do I do that? Simply say main, just like that. No need for ceremony and noise. And what do I want to do in the main function? I'm going to simply say hello world, just like that. That's my main function. So then what I can do is I can simply say over here, all I'm going to do is say Kotlin, Kotlin C. So Kotlin C -JVM. So this says compile it down to bytecode. And then I'm going to say sample.kt. And what does this do? It compiles it down to sample.kt class. Now I can say Java minus class path, and I'm going to simply say sample.kt and run that code as a Java code, class path dot of course. So when I run this, that is Kotlin code compiled to the JVM bytecode, and I'm able to run that right there. Or what you can do is get rid of the .class files over here, we don't care about it, and then going back to this, I can say Kotlin C .js. I know that's a little scary, but you can compile it down to JavaScript. And of course, once you compile it to JavaScript, of course, it specifies the output file. In this case, it says. So let's go ahead and try it. -o stuff.js. So in this case, of course, invalid argument. Specify output file using the output. Let's go ahead and see. It helps if I read it. So output. So let's run that and see what it provides for us. So right there is stuff.js. And you say stuff.js and you take a look at it. That is JavaScript compiled from Kotlin. Don't complain, could have been worse, could have been PHP. So the point really is that you can compile it down to JavaScript as well, good old JavaScript, and you can run it. Or you can do Kotlin, and you can compile it to native. And you can compile it into the binaries on the platform you want to run it. And you can run it as a Kotlin native. Or you can do WebAssembly. And then you can run it within browsers as well as a WebAssembly. Or you can compile it to, Android devices as we saw earlier. So this is one of the languages that's poised to compile it to various different targets. And as a result, you can write code in just one language, but you can switch between different deployment platforms. You can use all the power of expressive code and elegant code and concise code to create DSLs, to write coroutines, to use a better inheritance or better delegation, to write object-oriented code, or you can write functional code as you saw earlier, or you can write imperative code. The language purely gives you choices. The language treats you as an adult and says, you decide what makes sense for you, rather than the language telling you that's one right way to do. But whatever you do, every single one of them is more elegant. I mean, honestly, even when I write imperative code, imperative style code, it doesn't feel as bad as writing it in language like Java or C#, because it's a lot less verbose and they do a lot of right things. Like, for example, making variables immutable where it makes sense and so on. So as a result, it's designed as a better, elegant language. And that is one of the benefits you get out of this. And of course, in the case of Android devices or other platforms, you can use the features like lambdas and functional style, even for versions of Java before Java 8. So it gives you the best of both worlds. You can be using all the good qualities of functional style of code, but without having to be switching over to the versions of Java that provides it, so you get the best of both worlds in that regard. So that's one of the biggest benefits you get out of using this, is it makes life a lot easier. Any final questions or comments?
What's the price for performance you pay when you compile it to something?
Yeah, so essentially when you're compiling it, you're pretty much compiling it to bytecode at that point. And when you compile it to bytecode, it runs on the JVM. And the bytecode is not inefficient like in a lot of other languages, pretty non-efficient. No overhead from that point of view. But of course, if you're compiling it to JavaScript, at that point it's JavaScript. It's not going to be as short and concise as the JavaScript you write, but performance-wise, it shouldn't have much impact at all. If it does, then you need to really rethink about what you're doing. Same thing in WebAssembly. When you're compiling it down to WebAssembly, it's running the binary at that point, so you're not going to incur the overhead at that point. Yeah.
So, as I have understood, I can compile the same code for JVM and for native.
Almost the same code. So think of this as a language. So here's a way to think about it. So let's say I speak English. I can order a ferry in a city where there's a beautiful ferry. But I cannot go into the middle of Oklahoma and order a ferry, for example, right? So the language is English, but the APIs are different. So if you are using JavaScript or WebAssembly, I'll be using, let's say, take an example of WebAssembly. I will be using, let's say, the HTML5 DOM API or HTML5 Canvas API. Well, I wouldn't take that code and compile it to JVM, obviously, because the HTML5 is available only on the browser. But it's the same Kotlin code, the concise code I'm writing, just like I can ask for a ferry in one place but not in another place, even though both are English language. That's a way to think about it. Please.
Yeah, you showed a lot of great things about the Kotlin as a language, but
Oh, wait. You say you showed a bit of things in the language. Thank you. Not the word but. No, just kidding. Go ahead.
yeah, but the question is, what are the common and main problems that Kotlin developers are facing with this language?
Yeah. So one of the first things is the language is in development in different phases. Kotlin native is very promising, but Kotlin native is far from being done yet at this point. So don't trust it too much in terms of, I'm going to jump in and do everything in production. Take it a little slow. Kotlin WebAssembly is still in development for compiling into WebAssembly. There are a number of APIs that are not done. In fact, it's even worse. There are only 2 libraries that are available right now. So if you want to do a full-blown WebAssembly, you're not going to be able to do it as of today. That's another problem you're going to run into. One of the other things people often, this is more of a myth than anything else, people think incorrectly that to use Kotlin you need IDEs. I showed you that's not true here already. You can use a command line, you can use a very lightweight editor. You're not required to use Android Studio, or you're not required to use IntelliJ. You can do a lot of stuff in the command line. Or in a very lightweight IDE or editor, other editors. And so there's a bit of a misconception on people as well when it comes to that. When it comes to integrating Java and Kotlin, I would say the story of integration is a lot better, but it's not completely a happy story. Part of the reason for that is the concept of coroutines are very powerful in Kotlin, but don't try to call coroutines from Java into Kotlin. That can be really a nightmare. Because the reason for that is Kotlin compiler performs a huge amount of syntax sugar for you. What will be so natural to write in Kotlin, you will sit there and scratch your head, how do I write this from Java? Some of them are going to be really hard. Part of the reason for that is there is implicit object that comes into your context and you cannot use that so easily from Java. One other thing to think about is how do you do automated testing of your code? So there are a couple of different answers for it. You can use JUnit, of course, if you want to, but there's also a Kotlin test, you can use it. But what about mocking? Well, people use Mockito for Java, you can use Mockito, but the problem is you want to have a mocking or a stubbing library which is very natural for Kotlin. Well, you could use mock, M-O-C-K-K. The documentation is painful. And to unit test coroutines is not that easy. You got to work a little harder to do that. It's not impossible, but it takes a lot of effort to do it. So the learning curve can be really high in some of those edge areas. And you need to, and these are the areas where, you know, one of the problems is good developers learn quickly, but even then, if the testing is really hard, they try to wimp out of it. Well, you want to make testing extremely easy so developers don't have any excuses. We're not there yet, in my opinion. I have to spend a lot of effort to write automated testing in the way that I want to, where it's elegant and concise. But I'm usually a guy who likes fighting with the languages and compilers. I would literally spend 3 days of my life doing absolutely nothing and just spend the time fighting with some tools or technology only because I can. Because I get paid to waste my time. But a lot of people don't get paid to waste their time, unfortunately. And as a result, that can become really frustrating for them. So that is one of the things to consider as well. So those are some of the high-level negatives to think about. Over time, those will get better, but be careful though. Should we call it a night? Oh yes, go ahead please.
What is the editor you use for examples? Like this lightly idea.
Well, so which one?
The editor you use
Oh yes.
for examples.
Right. Yeah, so this is purely TextMate. It's a very old editor on the Mac. I got tired of flipping slides a few years ago, so I kind of decided to go no slides. And it keeps me awake mostly, so that's why I don't use slides. Yeah.
As I understood from your previous explanation, Kotlin provides one interface for example, for collections of different implementations for, say, JVM and Android.
Yes. Yes. Well, so no. So what I was explaining was that Kotlin uses the JDK on the JVM.
Yeah.
Kotlin uses the JDK array list, but on top of it gives you two interfaces. One is the list interface, which is immutable, and a mutable list interface, which is mutable. So here's the deal. If I were to say val fruits, for example, is equal to mutable list of, let's say, apple, but this type here is a mutable list of, let's say, string. So in this case, what I have is, if I were to print fruits, what is the type of this fruits that we are dealing with? Let's make, okay, you know what, pardon me here. So let me come back to this in just a minute. So let's go to, let's blow away the stuff, and let's move sample to sample.kts, and now let's edit the sample.kts. So that should work. Right. So when I run this code, what does that do? That's Apple. But I want to know what is the Java class for this particular class we are dealing with. What is the type of that? Well, that is going to be .class, I suppose. So this is going to be the object, whatever the type of that object is. So you're going to be using the array list type under the hood. So it should be Java class, but anyways. But what is this mutable list? I can say val f is equal to, and this could be a list of, let's say, string is equal to fruits. And I'm going to look at the value of f. So we are getting two references to exactly the same object. However, if I were to say over here, fruits dot add, and I'm going to say in this case, orange, so the f is really the same object as well that you are getting. Oh, but of course I printed before I modified it, and then I modified it and f contains it. But if I say f dot add, and I say banana, I cannot do that because this reference is an immutable reference. So you can get two references on the same object. One is mutable, the other is not mutable. And then you can do that, as you can see. So you can decide when you create it, internally you could keep something that's mutable, but externally you could give something that's immutable. So that can make your code a bit more safer.
What about licensing? I know that Java became paid for now, yeah? And what about this Kotlin?
So JetBrains, pretty much it's open source. It's as freely available as it is.
Yep.
From what I know, they have no intention of charging people who are using it.
For now.
Well, I trust them a lot. And I think that they genuinely are interested in continuing to do what they're doing right now. Ted?
So part of the thing to remember is that Google is actively trying to get out of the Java game because of the various legal issues that they've gotten into with Oracle over the use of Java. And Kotlin can now compile straight to native, which means essentially that this gives Google an opportunity to completely bypass all of the JDK and all of its tooling and so forth. Plus, now if you do Android development, what is the IDE that you use? You use Android Studio, which is basically a stripped down, burned-in version of IntelliJ IDE, which means that if you're going to start thinking about doing development on other platforms using other languages, what are you going to do? You're going to try to use something that's familiar to you, like, I don't know, JetBrains Writer, or IntelliJ, or PyCharm, or WebStorm, or... So, in this particular case, JetBrains is not thinking about trying to get money from the individual developer. They're trying to get you hooked. They want you addicted to their tools so that when you go and want to do professional development, you'll use some of their other tools to do it.
Hey, if you're going to have some addiction, I would rather have that addiction.
No, man, Diet Coke is pretty tasty. So.
One question. You seem very enthusiastic about Kotlin, but I believe you have some some history with C#. Now, in your opinion, now is C# really that terrible?
Oh, I'm excited about everything. You just saw me excited about Kotlin right now. I'm just a guy who gets excited, that's all.
So C# is still okay?
Oh, all the languages are still okay. I never tried... Huh?
Not Perl. Perl's terrible.
I'm not talking about the ones that start with a P.
Python is okay.
Really?
I like it.
That's a problem. I mean, one of the things I always emphasize is, to me, I love languages. And I will enjoy different languages all the time. And I like C# as much as I like Java, as much as I like Python, as much as I want to like PHP. I mean, these are different, no?
You do not want to like PHP. I've known you.
But he looks like a nice person, except for wearing a null shirt.
Dude, he's dangerous.
Look, you can't see from here. His charm. He smiles. He looks like a...
All I can see from here is danger.
Is null, yes. he is like Kotlin's list type. He's got two different interfaces. Yeah, so I mean, I respect these languages. They are powerful for what they do. But the thing is, when you are polyglot, you have the ability to... So let me put it this way. I see programming languages like they are vehicles. There's a bicycle, there's a car, there's an airplane. On a given day, I tend to use multiple vehicles, and that's the way I can get around. And there are times when a bicycle is a better tool on a crowded street or a local neighborhood than a car, for example. So I do like these languages for that reason, and I think to us the programmers, our capability is our ability to leverage the tools to the best extent possible given the context.
Thanks. Well, it seems very cool. I'm sold. Too bad that it doesn't run on .NET Core yet.
You know, eventually, yeah.
Could you name some enterprise frameworks similar to Spring or Hibernate which would use Kotlin in more natural and fluent ways?
Yes, Spring.
Micronaut.
And I was not, sorry?
Micronaut as well.
Micronaut. So, thank you. So let's talk about Spring for a minute. The Spring team has heavily invested, and they have created what they call Kofu, K-O-F-U. And Kofu is a library written using Kotlin first, and Pivotal is investing heavily into Kotlin. Micronaut runs can be written using 3 languages. You can write code in Java, you can write code in Groovy, and you can write code using Kotlin as well. And the beauty is any library used in Java can be used from Kotlin as well, but then there are libraries that are moving towards providing smooth API for Kotlin also. So that's happening too. Absolutely.
Any real-life example
Of?
Kotlin being used to build something?
Oh, a lot of them. More than 75% of Android applications, as one example, are being written using Kotlin today. A lot of Spring applications are being written using Kotlin. I also know companies that are using other tools, Micronaut and what have you. But if you go to the Kotlin's website, you'll see references to a lot of companies using this. But I personally know quite a number of companies that are heavily invested into this.
Gradle has a Kotlin-based DSL as well?
Yes, it is. I do have to say, it's been a bit of a hard journey for me. I've been using Gradle for a long time, and I've been using Gradle with Groovy for a long time, and I switched over to using Gradle using Kotlin maybe a year and a half ago, and it was not an easy transition for me. Maybe it's because I was so used to the Groovy APIs, it was not easy to transition. But it works really well once I figure out exactly what things to do. But yeah, you're right. So Gradle invested quite heavily into Kotlin as well.
And And I will mention, so I live in Redmond. I used to work for a company called Smartsheet. Their mobile team just within the last year or so made the wholesale commitment to move over to using Kotlin as their first language of choice. So they're slowly porting their Java code over. And I teach mobile development at the University of Washington, and a lot of my students, we started doing Kotlin 2 years ago because the writing was on the wall, and sure enough, most of the mobile companies in the Seattle area, they're preferring to hire people who are Kotlin first when doing Android hires. So it's definitely, the sea is rising, it's changing, it's becoming a Kotlin first Android world.
It's a Bitcoin.
And we're done.
I think let's finish now, and if you have more questions, you can ask still Venkat and then Ivy. Thank you.
Thank you.